try to go on to the next speaker. Let me try to. That is Mr. Sohari Nandakumar. Mr. Nandakumar works currently in NPOL DRDO Trivandrum. 11 years of experience in software design and development, 2 years of industry experience in machine learning, 2 years of industry experience in developing system softwares, signal processing systems, etc. And he has done his MTech computer science with specialization in image processing from CUSAT and BTech computer science from CUSAT. So over to Mr. Nandakumar. Please share the screen.
Yeah, sure. Can you hear me, sir?
Yeah, I can hear you.
Okay. So first of all, I want to just make a correction. Actually, I am not working with NPOL. I am working with Kerala State Electronics Development Corporation. There is a misunderstanding, I think. When the organizers invited me, I was deputed at NPOL for a project. Maybe because of that, this mistake happened. Sorry for that. Anyway. Okay, so anyway, I thank Mr. Deepthi Kalyan Saha because he has covered anyway 50% of what I have planned to cover. So that is, I mean, so I think I will get, I will invest more time in the rest of the, with just 50% of my thing.
Yeah, your screen is visible.
Yeah. So what I am trying to, my topic is like Python tools on Linux, powerful Python tools for machine learning. So there are so many Python tools, Linux tools, open source libraries in machine learning and deep learning. So what I am trying to do is, there is no time to demonstrate all these tools and all. So I am trying to give a motivation so that anyone, if you are not familiar with any of these open source tools, I'm just trying to give a motivation, just familiarize things, and you can go and try yourself in your lab or home or anywhere. So that is what I am planning. So directly into the topic. Here I am using Python notebook. I think everyone is familiar with Python and Python notebook. Python notebook is nothing that is just like a IDE where you can just type your code and you can run. So this is Jupyter Python notebook. In any Linux flavor like Ubuntu or Fedora or any Linux flavor, you can just install this Python Jupyter notebook from the software repository, or it is also available for Windows platforms as well. But I feel these libraries are more powerful when you use in Linux platforms, so I recommend you to use in Linux. So directly, so first I would like to introduce the Numpy library in Python. So Numpy is nothing but the numerical Python. So you can see here, just a minute. Okay, you can see here I have just imported. This is so you can look into this code. Wait a second. Okay, so you can look into this first line of code where I have imported the Numpy library to my Python. So I am just running that code. So it has run. So we know in machine learning we have to use linear algebra, right? We will be representing our data in matrices and arrays. So linear algebra is a must thing in machine learning. So in numerical Python you can create n-dimensional vectors or n-dimensional matrices. You can do matrix multiplication. You can do slicing and everything. So this is how we create a vector. So I am just creating a vector 1, 2, 3, 4. So for that I will call np.array. Actually here I have imported NumPy as np. This np is just an alias name for the NumPy library. You can give anything here, but conventionally we use np. So if you import like this, you need not type everywhere NumPy. You can just type np. So here I have just created a vector. So that is 1, 2, 3. 3 elements are there in the vector, and I am just printing the vector here. So you can see the output here, and you can also print the shape of the vector. Shape in the sense the dimension of the vector, not the dimension, the number of elements in the vector. Okay. Also, you can create matrices in Numpy. So to create a matrix, you can create a two-dimensional array or a two-dimensional vector. So here I have just created np.array of 1, 2, 3, 4, 5, 6. This is the first row, 1, 2, 3, and this is the second row, 4, 5, 6. I am just creating it and printing it down. These are very simple stuff. Okay, so many such vector manipulation, matrix manipulation functions are there. You can go into the Numpy website and the manuals available online. And here also I have just there are other functions in Numpy to load data from your files or I mean text files and all. So this is just a small function to load data from a CSV file. So this is load text. Load text is actually a function to load data from a text file. So I am just opening the file inside. So this open is actually a file opening function in Python. It will open this file and will return a file handler to this function. And I have also given the delimiter as comma. Actually, I have a file like this here. So you can see this. This file, so it has so many data. So this data, suppose I'm just having two data. I have just one x value and one y value. Okay, so these are so each x and y values are separated by commas. That's why I give here delimiter as comma. You can see it is comma. So if you run this line of code, it will read this particular file and will load that file to data. And I'm just printing the shape of the data. There are 96 rows and 2 columns. Okay. So now what I am trying to do is to just fit a linear regression model using this data. Mr. Deepthi Kalyan has already introduced you the sklearn. Sklearn is another powerful Python library available for machine learning. This is actually scikit-learn. It's scikit-learn. We call it sklearn. So this is also an open source library. So to fit a linear regression model, I'm just importing the linear model class. This is just a class linear model. So from the sklearn library, so I'm just importing the constructor of that particular class to the this program, and then I am just creating a linear model. I mean a regression model. That means actually this is a constructor. Hope you all know the class and object concept, the object-oriented programming concept. So in the object-oriented programming concept, when you call a constructor, it will create a class of that particular the class of the to the class which it is attached. So it will create a small object of that class, and it will return to this to the assigned variable. So here I am just calling that constructor for linear regression. So I'm just calling the constructor for linear regression, and here I am passing fit intercept is true. Fit intercept is true is nothing but, suppose if you have a univariate linear regression, suppose take a univariate linear regression. Univariate linear regression means the feature variable is only a single variable. You have only a single x variable. Then what will be the hypothesis? I mean, what will be the model? I mean, the generic form of the model. It will be maybe x or y is equal to w1x or w1x plus w0, or theta1x plus theta0, where theta0 and theta1 are the parameters, right? We may call it as a slope intercept form, while normally that is the equation of a line. Y is equal to mx plus c, where c is the intercept, right? So there is one intercept part also in the linear regression model. So do you really want that intercept part or not? That what we are giving here. I choose to have the intercept part. So I'm just running this code. After, when you run this code, you will get a linear regression model in this regr variable. Okay, then what I am doing is I am just creating the xy data for training this model. So here in the previous line of code, I have just loaded the data from this CSV file to this data object, and now what I am doing is I am just slicing that data because it is having both x values and y values. So I want to separate the xy values. So this is another powerful method available in Numpy. You can just simply size n-dimensional matrix into any dimension or any range. This means here, if you look into this code, it means I am just taking all the rows of the column but zeroth column. All the rows of the data but only the zeroth column. Okay, so the column means all the rows. If you give the column in the first part, it means all the rows, and the 0 means all the column. So I just want to take the first column, right? First column is here, it's 0th column, so that is the x value. So I am taking the 0th that first column to x, and then just I will execute that part also. Okay, then the next line of code, I am just printing the shape of x and just reshaping x to 96.1, because if you I will show you the output, then you can understand. If you see the output of print x dot shape, it is just 96 comma, because it is a vector. We want to convert it into a matrix form, a 96 1 matrix form. So for that I am just reshaping it to x dot reshape. This is another function available in Numpy. You can reshape the the matrix. Okay, so I have reshaped it to 96.1. Then I am taking the y data. So I have so for y data I am taking all the rows and the second column. Here second column's index is 1. That's why I have given 1. So all the rows and the second column I am taking to y. Okay. Then again I am reshaping that too. So you can see its shape is also 96.1. Now we have the x values and the y values. Okay. So in hope all of all at least know the basics of machine learning. So in machine learning, when we have a data set, what we normally do is we split the data into train and test set, right? Because after training we need to test how the performance of the model we have trained. So there is a function available in the sklearn model selection object, that is train test split. So I have just imported that function to this Jupyter notebook. So the train test split, what it does is it will split the training data or the data available into train and test data in a particular proportion. So it will return actually four matrices or four matrices. Actually the first matrix will be the x train, and the second matrix will be the x test, and the third matrix will be the y train, and the fourth matrix will be the y test. So the parameters I pass is of course the x and y data available, and then the test size is equal to 0.3. This means 30% will be the test size, 70% we will be using for the training, and random state is equal to 42. Random state is nothing but it doesn't if you run this method, it will not take like a first 70% I will take for training, and the rest 30% I will take for testing. Not like that, because that there will be some bias for the first 70% data or something like that. For that, actually it will randomly choose 70% for testing. So when you choose randomly, next time when you take the run that function again, you will be randomly choosing another 70%. To avoid that, you can give a random state. So whenever you give random state is equal to 42, it will be randomly choosing, but always choosing the same data, the same data available in the data set. So for that we are giving random state. So I am running that also. So now we have the x train and x train, x test, y train, y test and available. I will just print the shape of that. Print so it is 67.1. Before it was 96. So out of 96 I have taken 67 for the training. Okay. Rest 29 I have taken for testing. Okay, now I am just training the data set. For training, in almost all data machine learning libraries available in Python, we use a function called fit. Even you write a custom class, or even when you inherit a class from some other library, or you are doing it from the scratch, we normally, there is a convention, we will write the training function as fit. So here this fit function, this is available inbuilt in the linear regression model available in sklearn. So I am just calling this fit function. Here you notice this regr this is the object of the linear regression model that we have initialized here. Okay, so I am calling regr.fit. To that I am passing the x train and the y train. So I am running that. So that has trained the model and fitted the model. Okay, now I just want I am trying to print the parameters here. Parameters means now what we have fitted here is actually a model like y is equal to mx plus c, right? Or y is equal to ax plus b, or y is equal to theta x theta 0 1x plus theta 0, something like that, where the a b or m c etc are called the parameters, right? So I'm just trying to print the parameters here that we have learned. So machine learning in the others we also call it as a parameter learning, right? Actually we are selecting one model and the model have a lot of parameters and we are trying to learn the parameters, right? So I'm just printing the parameters we have learned in this step. So here here we have only two parameters. One is theta 0 and other is theta 1. This is theta 0 and this is theta 1, or a and b, or whatever you call it, or weights. Some people, even you are familiar with the deep learning, we call it weights, w0 and w1. Anyway, this is the w1 and this is the w0. So in sklearn's linear model, it is available as intercept and coefficient. The intercept is actually available in separate, so you have to print it separately, regr.intercept underscore, and the coefficients you will get it as a vector. So you can print it here. So I have just printed the learned parameters. I mean the learned parameters here. So now we will just try a prediction with the testing set we have. So for that we use regr.predict. This is also inbuilt function available in the sklearn linear regression model. So I am just predicting it with the x test. X test is our testing data, or 30% testing data. So I have just predicted it. We have the ypred here. Ypred is the predicted data. So so once you predict it, you can just compare the predicted values with the real values. Where is the real value? The real values you have in the y test. Right, in the y test we have the real values. We are having 96 data. Out of that, 67 we used for training, and 29 x values and y values we have. With that 29 x values we have predicted a ypred. So you have 29 ypred values here. So that ypred values I am just comparing with the y test, that is the actual value, using the mean squared error. So so I am just trying to familiarize the different submodules available in sklearn. So sklearn.metrics have all these mean squared error functions. You may be using log error in classification and all these error functions are available in sklearn.metrics. So now we are just using the mean squared error and just printing the calculated mean square error. So that is how to fit a simple regression model, linear regression model. Now we will try to fit a polynomial regression. Okay, so I'm also here also I selected a very simple model. So what I am doing is I am introducing another module that is available in package available in Python, that is matplotlib. Matplotlib is actually a plotting library where you can have plots, 2-dimensional and 3-dimensional plots. So this is very much helping when you are doing some research and all, how the data, where it is lying, what is how the model that we have learned is performing and all. So I'm just importing that, importing the matplotlib.pyplot. Pyplot is a submodule available in matplotlib as PLT. Okay. Then I am just creating some data. Before we read the data from, we read the data from the CSV file. But in this polynomial model, I am trying to create some data my own. So here, I'm just using, hope you are hearing me, right? Hello? You can hear me, right? Yes. Okay, thank you. So, so I'm just preparing data. So I'm using a function np.linspace. np.linspace is nothing but it's a function that creates 100 data. You have to pass 3 parameters to that function. First parameter is the starting point, and second parameter is the ending point, and third parameter is the number of data you want. So it will create 100 data between 0 and 0.5. Okay, so it will just create 100 data between 0 and 0.5. So I'm just printing the shape of that x. Then I'm actually this is the x value, so I am creating the y values. Y value, actually I am taking a cos function. I am taking cos square 2 pi x as the y value. So I am just taking y actually is equal to this is np dot cos. You can use this all trigonometric function, all trigonometric functions are available in NP. You can use np dot cos, np dot sin, like that. So I'm just taking np dot cos 2 pi x square. So that is cos square 2 pi x. Okay. So, and then I am also printing the shape of that y, and also plotting that. We will see how it will plot. See, this is how it's plot. Okay. So this is actually our y value, not y value, y actual. Now, so there is no point in learning a well understood model, right? Here the model is cos square 2 pi x. So no point in learning that. So I am just trying to add some data, some noise to this y value. So for that I am actually creating some noise. Actually I am using another function which is random np.random.normal, and giving 3 parameters in that function. First parameter is the starting value, or the first 2 parameters are the range, and the third parameter is the number of values I want. So what it will do is it will create a random 100 data in between 0 and 0.1. So I am just running that and printing it so you can see it. Okay, so I am just creating data. Actually it may vary from I think it's vary from 0.1 to minus 0.1 or something like that. Anyway, I have created some noise. So that is very small values I have created, and I am just adding that noise to my y values and again plotting it back. So here I am using 2 plots. Before we plotted using the function plt.plot, that is a continuous plot actually. And there is another plotting function that is plt.scatter, that is a scatter plot. So what I did is I calculated this y actual as cos square 2 pi x, and then I have added some noise to the cos square 2 pi x values. So I have 100 cos square 2 pi x values. X varies from 0 to 0.5. So I have 100 such values. I have added a small noise to it, and I am plotting it again, plotting the both values. In the continuous plot I am plotting the y actual, and the scatter plot I am plotting the y value I have calculated here, adding the noise. Okay. So here it is. So this is nothing but the blue graph you see here is the actual value, that is the cos square 2 pi x, and the red dots are the y value, which is the cos square 2 pi x plus some noise. Okay. Now again I am trying to fit a linear model for this. For a linear regression model I am trying to fit for this. But we know the linear regression model will not be much enough to fit this, but I am just trying a linear regression model here. I am just that we know that, so that's why I am just quickly running all the code and printing the output. So what I did, I just created a linear model that we saw in the previous example also. Linear model dot linear regression fit in respect step 2, and I also tried to fit xy values, and then I predicted with the x values, the same training set I use for prediction. Then I plotted in green color. We know you will be getting simply a line because you are using a linear regression. So definitely it will be a line, and we know it is not a good fit. So I am trying a polynomial regression for the same. So you already know polynomial regression. In polynomial regression what we are doing is we will create polynomial features actually. In polynomial regression also we are actually doing the linear regression, but before doing the linear regression we change the features to polynomial features. Suppose you have x, you will take x square or x cube or something like that, and x square you will take, x raised to 3 you will take, x raised to 4 you will take, and all these will treat as separate features. That is how we do the polynomial regression. So for that I am doing I am importing 3 submodules in sklearn, that is pipeline, polynomial features, and standard scalar. This pipeline is a wonderful submodule available in sklearn. In this what you can do is you can pipeline different models. In the previous lecture Mr. Deepthi Kalyan has explained how you will do the pre-processing and all in natural language processing. In natural language processing, you will do a lot of pre-processing. You will be tokenizing the sentence. You will be avoiding the stop words. You will be creating bag of words. You will be finding the TF-IDF score and all. So these you need not do one by one. You can just import the models, or you can create. You can create the models and you can pipeline those models. So that is what I am using in that is what the pipeline does. And the polynomial features actually convert the linear features to polynomial features, and the standard scalar, no, that what it will do is it will normalize the data. Hope you all know normalization. I mean, normalization nothing but the keeping the value to a specific range. So so I have just imported that, and I am I am selecting the degree of the polynomial features as 2 and running the same, and again fitting the data, and then predicting, and also just trying to plot the same. Now you have a better model. You see the green graph here, that is what the model predicted, so it is performing better. Now I'm just increasing the degree to maybe 20,000 and doing the same. How it will do? It will take a little time and some more seconds. See now now it is much better. No, you cannot say this is better. Maybe it's little overfitted. So this is how you do a simple polynomial regression in sklearn. So that's it. And next I want to introduce you the natural language toolkit, but that already Mr. Deepthi Kalyan has explained you. That is a wonderful library. You can go, if you are really interested in NLP, you can go and study that. And another module that is available in package that is available in Python is Pandas. Pandas is nothing but it stands for Python Data Analytics Analysis Library actually. So this is not nothing related to directly related to machine learning, but this will help you a lot in machine learning. Like in Numpy, one limitation is Numpy matrices can only hold numerical values, but Pandas matrices, you will not call matrices but data frames. Pandas data frames, that is same as metrics, that can hold numerical values, boolean values, text values and all. So you can do a lot with Pandas. I mean, the pre-processing and the data preparing and all these things we can very simply do it with Pandas. So you go and try Pandas too. So that's it. Now I will move on to PyTorch. So PyTorch is a very new library available for deep learning. So PyTorch while you are doing deep learning, if you are not having much resources like GPU and all, one good choice is to go to Google Colab. So I have a Google Colab Python notebook here. So I'm just introducing PyTorch here. So Google Colab is actually a cloud runtime environment, where if you look into the runtime menu, you can go to the change runtime type. There you can actually enable a GPU, so that you will get a GPU to run your deep learning code. So in running a 100-layered neural network and training it in your local system will be very difficult. So you can use this this cloud runtime. So I'm just again just try to familiarize you with the PyTorch. What is the advantage of PyTorch? So I just imported the PyTorch. The PyTorch also, in PyTorch the matrices you create are called tensors. Why we call tensors there, I will explain you. I'm just using creating some ones, zeros and some random matrices in PyTorch. Torch.ones, torch.zeros, torch.rand and all. And now I will just show you how comparison between PyTorch and Numpy. See, here I have a matrix multiplication. I am multiplying 1000 into 1000 matrix 100 times. Let us see how much time it will take if you do it in Numpy. Here we are using Numpy. Okay, here we are using Numpy for doing this matrix multiplication. We will see how much time it will use. If you give a percentage time in a Python notebook, it will calculate the time using for this particular cell, and it will print it down. So we'll see how much time it takes. It takes 17 seconds to multiply 1000 into 1000 matrix 100 times. We'll do the same with the help of a GPU and PyTorch. So to initialize a GPU that is available in Google Colab, you have to run this part of the code. I don't have much time to explain what it is. You can just write to, I will give you my mail ID and you can write to me, so I can explain this, what this is. It's very simple. It is just initializing the GPU available in the Google Colab, Google Colab this runtime environment, and I am creating torch.ones A and B. I am just putting this A and B. These are two matrices. Matrices, we call it tensors in the GPU. I am creating it in GPU, not in.
10 minutes started.
Okay, so I have to stop it now, or can I continue for another 2 minutes?
Yeah, you have that 10 minutes time. Okay. So if you finish it, then you will have interaction after that.
Yeah, sure. So I have just created this matrix A and B in the GPU, and I am doing the same, the 1000 into 1000 two matrices I am creating, random matrices, and doing that for 100 times matrix multiplication. I am doing for 100 times. We'll see how much time it will take. See, it took only 22.5 milliseconds. Where in Numpy, we did it with very normal CPU, it took 17 seconds. And here, it didn't even took 1 second. It didn't even took 100 milliseconds. It took only 22.5 milliseconds. That is a magic. So that is how Pytorch will perform with the help of a GPU, and of course you can use the GPU available in the Google Colab free of cost. If your GPU you don't have a GPU available in your lab or in your company or all, because I will not recommend you to always use the Google GPU, but if you don't have that environment with you, you can use this. Okay, another very important feature available in Pytorch, not only in Pytorch, almost all TensorFlow kind of deep learning libraries, is the auto diff. Why we call this tensor? These matrices that created in Pytorch are called tensor. Why? Because in a artificial neural network model, what do? There is a thing called backward propagation, right? Hope you all know. That is, in the learning, what we do is the gradients. I mean the derivative of the loss function. That you have a loss function and in the model, and the derivative of the loss function with respect to each parameters in the model is very important. Okay, depending upon that we learn the parameters, right? So you know the gradient descent roll and all. Okay, so what is the specialty of this auto diff is, when you create a matrix with this option recurse grad is equal to true. Here I am just creating a torch.ones of x. So what it will create a 3 into 2 matrix with all elements as 1, and I'm just printing it. So it is 1 1 1 1, and here I have given recurse grad is equal to true. Then I am taking y is equal to x plus y and printing y. So all elements will be 6. Then I am taking z is equal to y square plus 1 and printing it. So all elements will be 37. Now I am taking the sum in t. Okay, then the sum will be 222. Now I am doing a simple thing, that is t dot backward. So when I call this t dot backward, what it will do is it will compute the derivative of t, the output of, so t is nothing but, we can know, I have written is t is actually z, sum of z, and z is equal to y square plus 1 and y is equal to x plus y. So it will calculate the derivative of this output at each level, So if you print x dot grad, you will get 12. That means the dt by dx at x is equal to 1 and y is equal to 6 is 12. So when you have a 100 layer neuron, you can simply calculate the gradients like this. There are much more things you can do with Pytorch, but we don't have enough time. But I think you can just go and explore these tools, and thank you. If I am open for questions.
Okay. We have questions in the chat box. Okay. So, are there any specific advantage of Python offers as compared to Matlab? Request to kindly mention comparisons on some common parameters.
Yes, of course. The Matlab, first thing is the Matlab actually is a it's a very proprietary software, right? So the contributions in active contributions to Matlab are very less. That is one thing. And the machine learning libraries available in Python are fast developing. I mean, there are a lot of contributions coming from the academic community all over the world. So we have so many deep learning libraries like PyTorch, TensorFlow, sklearn, and machine learning libraries like sklearn, then NLTK, SciPy, and all. So such things, I don't know that they are not. I don't think they are available in Matlab. That is the answer to that. And the second, okay.
How to decide best degree for the polynomial regression to avoid overfit as well as generalizing the model in Python?
That is a feature engineering question actually. See, when you go for a model, you cannot say that this degree polynomial regression will be better, good for this this thing. So what we do is we start with I mean, you will plot the data and see how the data lies, and then you start with a assumption. Okay, and then you can compute. I mean, everyone know about this. I mean, our bias variance trade-off, right? Bias variance trade-off. You have to look. You have to plot the bias and variance in a plot, and you can see how this grows when the number of features and the training epochs increases. Where is the loss and the where is the loss of the training set and the test set? So you have to study the bias variance trade-off very closely and to decide. That is not only for the degree of the polynomial regression, but for all machine learning training exercises.
Okay, how to translate a model developed in Python for deployment in embedded system? Which are the suitable tools?
Python for development in oh, sorry, I am not aware of any Python models that use in embedded. You can write to me and I will try to answer you.
Okay. It would be helpful if you could suggest a few Python libraries for GUI development.
Python libraries, I'm not, but you, of course you can have Qt. You can use Qt library with Python, and if you are using this web-based development, there is one library. I didn't remember its name actually. And anyway, I'm not a front-end developer. Sorry for that.
Okay. Okay. Then comparison between PyTorch and TensorFlow.
Actually, TensorFlow is also a very good library. I will not say that one is over the other, but PyTorch is completely a new library. So it is, I mean, what I feel is like PyTorch is more powerful and very simple to use than TensorFlow. Like creating networks and all are very simple. There is a module called pytorch.nn. In that and pytorch.sequential. Using these two modules, you can simply write a network. Like sequential, you can write a network. So if you are going for a much easy ways, PyTorch I will recommend. TensorFlow doesn't have such options, I think. But both are good. Both are good. Both are equally good, and I mean both are equally powerful.
So how do you define number of neurons / layers in Python?
I will show. Just I will show how I will do in PyTorch. See, you can see this, right? So this is actually I have just created a class. So I am using nn.module. So nn pytorch.nn is a module available. So I'm just inheriting that. So see this is how we create a network. See, this means first layer is a linear layer that have 2 inputs and 4 input that is giving to 4 neurons, and the output of the first layer is a leaky ReLU. You can even use ReLU or sigmoid or anything here. And again, it is giving from 4 neurons to 8 neurons. Again, the output of that will be a leaky ReLU. Then again, doing a linear from 8 to 4, and the end will be a softmax. So how many layers are there? 1, 2, 3, and 1 softmax layer. So 4 layers are there. So in the first layer we have 4 neurons, second layer we have 8 neurons, and the last layer we have 4 neurons and a softmax layer. This is how you can simply define a. But this varies. There are so many other methods as well. But if you just want to do it simply, you can do like this using nn.sequential. This is not common in Python. This is what I am explaining. This is the way in defining a a neural network in PyTorch.
Okay. In linear regression, there are measures like R square and adjusted R square, which give an idea about model overfitting. So this is just a comment. And can we translate Python or PyTorch code into C language?
I don't know, is there any, I don't think there is a inbuilt I mean a library to convert it to Python to Python, because Python is a very high level language and C is a very long level language, and I didn't find anything like that anyway.
Okay.
So Arindath, actually for no need to translate or Python into C, you know, when you do embedded firmware programming, mostly people use C. That is the next talk is going to talk about how people do that.
Okay.
So TensorFlow Lite, which is a special version for embedded systems.
Okay, that is in Python or in C?
It's in C. Yeah.
Okay, okay, okay. Oh, sorry for that. I didn't know that.
Okay, let us thank the speaker.
One thing I will do is I will share the notebooks in the Google Colab, and I will chat. I mean, put the link in the chat box. Thank you.
Thank you.
Thank you, Dr. Muralidhar, for conducting this session. Now let's take a break for maybe 10 minutes. So at 18:25 we can reunite. That is for mostly that is a demonstration, as Joby told. It's a demonstration class for all the young faculties and students. So 18:25 hours will meet. Joby, that's fine?
Yeah,
right?
yeah, 18:25 is fine. In fact, this is going to be very important for accelerator puzzle, because we are now talking about feeding the real signals, sensor signals, etc. into embedded systems.
So this will be a demo session, maybe.
So demonstrate. There are 3-4 demos on applications on TinyML. Okay, we will begin at 6:15, 6:20, like that.
Like already it's 6:15. So
6:20,
maybe 10 minutes break.